Our lesson for today is all about solution of a system of linear equations. To solve a system of linear equations is to find its solution. However, while some systems have an infinite number of solutions, others may have only one solution or may have no solution at all. A system of linear equations can be shown by two or more lines in the coordinate plane. The three possibilities that can occur for a system of two equations are illustrated here. If ordered pairs of numbers that satisfy an equation can be found, all the ordered pairs that satisfy every equation in the system can also be found. Remember, the set of all ordered pairs of real numbers that satisfy every equation in the system of equations is called the solution set of that system. Now, observe the graphs of 2x minus y is equal to 1 and 2x plus y is equal to 3, drawn in the coordinate plane at the slide. The line intersect at exactly one point which has the coordinates 1 and 1. Whether that point satisfies both equations or not can be verified easily. 2x minus y is equal to 2 times 1, which is the value of our x, minus 1, which is the value of our y in our ordered pair, is equal to 1. So 2 times 1 is 2, and then minus 1 is equal to 1. It tells that our equation is true. Next, for the linear equation 2x plus y is equal to 3, let's substitute the value of our y, or our x and y, by 1. So we will have 2 times 1, which is the value of our x, plus 1, which is the value of our y in our ordered pair, is equal to 3. So 2 times 1 is 2, then plus 1 is equal to 3. It shows that our solution is true. Notice also that the two lines have different slopes. One is positive and the other is negative. Recall that slope is the measure of the steepness of a line. It is the ratio of the change in y to the corresponding change in x. Next, in this graph, we have the graph of 2x minus y is equal to 1 and 2x minus y is equal to negative 5. Drawn in the coordinate plane are parallel. The solution set is the empty set. There is no solution because the two lines do not intersect. Notice that the lines have the same slope, which is 2, but different y-intercept, which is 5 and negative 1. Next, we have the graph of 2x minus y is equal to 1 and 4x minus 2y is equal to 2. Drawn in the coordinate plane coincide. The solution set of the system consists of the infinite set of points on the line formed by the graphs of both equations. Take note that the lines have the same slope 2 and the same y-intercept, which is negative 1. And these lines overlapped. If both sides of 4x minus 2y is equal to 2 are divided by 2, the result is 2x minus y is equal to 1. These two equations are called equivalent equations. And remember, a system of linear equations in two variables which has, first, at least one solution is called a consistent system. Next, if it has exactly one solution, then the consistent system is independent. Next, if it has an infinite number of solutions, then the consistent system is dependent. And last, no solution is called an inconsistent system. Now, let's have an example. So let's graph the system of equations and determine whether or not if it is consistent and independent. So let's find the x and y intercept of each line. From the first equation, if x is equal to 0, then y is equal to 3. So we have an ordered pair which is 0 and 3. Next, if y is equal to 0, then x is equal to 3. And we have an ordered pair which is 3 and 0. From the second equation, if x is equal to 0, y is equal to 3. Then we have an ordered pair which is 0 and 3. And if y is equal to 0, then x is equal to negative 6. So we have now our unordered pair which is negative 6 and 0. So how did we get that? So by substituting the value by getting the x and y intercept. So if we're going to get the y intercept, the x is equal to 0. And if we're going to find the value of our x-intercept, then y is equal to 0. Now, let's draw the lines using these pairs of intercepts. So we have 3 and 0 and 0 and 3 for our first equation, which is x plus y is equal to 3. Next, let's plot the point of our second linear equation. We have negative 6 and 0 for our x-intercept and 0 and 3 for our y-intercept. And this is the graph of our x minus 2y is equal to negative 6. And check whether the solution of the system satisfies both equations. Now, from here, the solution is 0 and 3. Now, let's check. Using the first equation, which is x plus y, let's substitute now the value of our x and y, which is 0 and 3. So we have 0, which is the value of our x, plus 3, which is the value of our y from our solution, and 0 plus 3 is equal to 3. And the solution is correct. For our second linear equation, we have x minus 2y is equal to negative 6. Let's substitute the value of our x and y, which is from our solution. So we have 0 minus 2 times 3, which is the value of our y, is equal to negative 6. Then 0 minus 2 times 3, we have negative 6. Since 0 and 3 satisfy both equations, the system is consistent and independent. I hope you understand our lesson for today, and that is solution of a system of linear equations. Again, this is your friendly math teacher, Sir Cielo. Goodbye!